All right, so where are we in this process? Well, we drew our house. And if you go right down your step-by-step instructions, it'll kind of do this. So let me just do that. We did our project tab. We did our libraries. We set our defaults in the libraries. We imported our floor plan. We scaled it. We drew our rooms on top of that floor plan. We created some vaulted ceilings. We grouped them. We put the windows on, and we went ahead and added that garage, which is fine. Okay. So basically, at this point, our house is done. Except for the ducts. We haven't got to the ducts yet, but the house itself, we have enough information to start our load calculation. All right. So the next step is to click the energy gauge load button. And that's in our step-by-step instructions.
Can I talk about the version? I think someone said zones.
What's the question? Zones are for multiple T-stats.
I think that's where CVEC stuff.
Yeah, that's a little different. So the definition of the term zone is different depending on the software that you're using. But generally speaking, a zone is a part of a house that's served by a thermostat. That's the way I typically do it. You can have multiple zones and multiple thermostats on a single system, and we call that a zonally controlled system, and that's usually accomplished with motorized dampers and stuff like that. Or you could have two separate systems serving two separate parts of the house, and those are zones too. But in Energy Gauge and Manual J, well, I shouldn't say Manual J. In Energy Gauge, they call a system a block, okay? As in block load. You've heard of room-by-room loads. You've heard of block loads. So they took that definition of a block, as in a block load, and says, okay, what part of the house are we grouping together as to be served by one system? Some people might call that a zone. But they don't. They just don't. Okay. And so in RightSoft, in Elite, and in Manual J, a zone allows you to do zonally controlled systems. But in Quick Model, it all depends on how you draw the ducts. If you draw all parts of one, let's say you draw half of the house served by one trunk, and the other half of the house served by another trunk, you could call those two zones and then draw a zone damper in each one of those two trunks. So it's all in how you draw the trunks, and the ducts sort of defines the zones for you. So if it's one system per zone, that's done automatically. If it's multiple zones per system, again, it's just all in how you draw the ducts. And we'll talk about that more tomorrow. In drawing your duct systems for, say, a zonally controlled system with motorized dampers and stuff like that, that's in the sort of the main D part of the discussion. Okay.
And then we have one more question. Are all of the construction assemblies from Manual J in the library?
Manual J is a bunch of tables. So what you do is you create a wall in Quick Model that picks certain parts of that table. Does that make sense? If you imagine a table is like a giant grid, and depending on which row you pick and which column you pick, those rows and columns come down to a point inside that grid. You can specify every single row and column that Manual J has, therefore create every single wall combination that Manual J will model. They just don't all come pre-programmed. As far as wall types go, you have frame wood, frame steel, you have concrete, you have brick, you have all those other. These all do come from Manual J. So if that's what you're talking about, yes.
A lot of these variables we ripped straight from Energy Gauge because we're just sending that information over to them to do the calculation.
Yes. Yeah. These are the pre-programmed assemblies and types that Energy Gauge comes with when they got approved to be an Acca Manual J software. Let me put it down. All right. So I think we're basically ready to do load counts. We've only got one system. I don't know if you noticed too, but this is kind of a cool feature that I had Connor do is your air handler. Go back to HVAC draw, select the air handler. it casts a shadow on the ground. Because sometimes in 3D, I remember when I was doing a lot of design work, getting that furnace to be in the exact right spot between the trusses, under the center line of the roof, next to the attic access, all that crazy stuff was really, really important, how you drew that. And sometimes in 3D, that's kind of hard to see. And so it casts a shadow onto the floor plan. So you'll notice in the floor plan, here's the attic access right there. So if you want to make sure that your furnace lines up right next to the attic access, that's what that little shadow is for down there. And as you'll see in a minute too, actually tomorrow, I'll go ahead and show you real quick. I'll give you a preview of tomorrow. Registers.
Quick follow-up question on the other one. Is that where you get the framing factors within the library?
Yes, framing factors are here. And right now it's just a fraction. If you want to change the framing factor, you'd have to look in Manual J to see, because I think this 0.15 framing factor is a 16-inch on center wall. If you want to go to a 24-inch on center wall, that's a different framing factor, and you'd have to look that up in Manual J. I think, and there's probably other sources for that. I know the California Energy Commission's Appendix JA4 has all the different framing factors for different wall assembly, 16-inch on center, 24-inch on center, 48-inch on center, and stuff like that. These are defaults. Honestly, they have a really, really small impact. They changed the U factor slightly. And in the grand scheme of things, the difference between a 0.15 U factor and a 0.17, you'll hardly notice the difference. But it does matter between a 16-inch on center wall and a 24-inch on center wall. That's a lot less framing, a lot more insulation. So it should have an impact, and it does on the heating side, not so much on the cooling side. Okay.
And then interesting question. Can a door be drawn in the ceiling for an attic hatch? I don't know if we have anything.
No, actually, that's a good question. So here's your attic access here. Most attic accesses are sheetrock with the same insulation, if they're insulated. In California, there's a rule that says your attic access has to have insulation permanently attached to it, so that when you open your attic access, that piece of insulation doesn't fall off and stay off. That's a really interesting question. I think you're getting really kind of precise here, but if you wanted to, what you would have to do is draw a little tiny room that's the same size as that attic access, group it with the rest of the room around it, and then the ceiling for that attic access, I assume you're assuming that it's like just uninsulated sheetrock is the attic access, and you want to account for that. You would just model it as a different roof type. So you need to isolate that. What is those typically? A 22 by 24. I think it's pretty 22 by 30. Whatever attic accesses are. You would just have to create a little ceiling that matches that, and then just assign it a different ceiling type. So yeah, you could actually do that. I think if you played around with that, you would find that the work to do that is a lot more work than the result you're going to get from it. But feel free. I mean, that's the cool thing about the software, any software, is you can do all these what if scenarios. What if this? What if they insulate the attic? Does it make a difference? What if they do this? Does it make a difference? And you can just make those changes, run your load calcs, and see. Okay? Interesting question. All right, so I think we're ready to take a break. It is 8 o'clock, and it's been about an hour since our last break. So let's take, it's a little after 8. Let's take a 10-minute break. We'll reconvene at about, what is the actual time? Oh, it's only 8:02. Yeah, let's go 10 minutes. We'll reconvene at 8:10. So everyone take a break, go get a drink. I'm doing okay. I was trying to think if there's any kind of side things I wanted to. Yeah, let me show you. This is not important stuff. This is kind of just bonus information. If you're taking a break, don't worry. I'm not going to give away any really important secrets here. But I did want to just kind of show you really quick our website. So let me change what you're sharing. Yeah. we need to.
Next to the where it says like the hang up button.
Yeah, but I have to get a web page out here where I have to get
Just shift tab to Chrome.
there it is. Okay, that's what I was looking for. Let me get to the page before I change the share. Actually,
I can just link it too.
I also want to show you, we have a pretty extensive YouTube channel that has a lot of training videos. So if you go to YouTube and you search for Hvac Model, Hvac Model, you'll come here and click on the videos. We have quite a few videos here. These two are a training I did for the National Home Performance Conference. This one here, this first one, shows you how to draw rectangular ducts in a basement. Okay, it says that, how to draw rectangular ducts in a basement. This one is the field draw demo, which we'll do a brief demo of that later on. There's one here, fun with data loggers. That actually has nothing to do with the software, but it has to do with using temperature data loggers to diagnose comfort problems in a house. This one is one, how well will it show it if I'm not sure. This is a 1-minute video, and it looks like you guys can see it okay. So what I'm doing here, I get asked a lot, about where to put supply registers, where to put return registers. And I try to explain to people that supply registers have much more impact on airflow than return registers do. So what I'm doing here is I use the example of a shop vac. So I take this shop vac and I spread a bunch of sawdust on the floor of my workshop, and I turn the shop vac on so that it's sucking air in. As you can see, in order for that sawdust to move, you have to get the shop vac right down on that sawdust, okay? But if I take that duct and I pull it out and I spin it around and I put it on the other side of the shop vac so that air is now blowing out of the shop vac instead of sucking in, watch what happens. Same CFM, same everything, it's just the direction of the air. Look at, from like 4 feet away, I can blow all that sawdust away, okay? And so what that is illustrating is that a supply register has a much larger impact on air movement in a room for things like mixing and stuff like that than a return grill does, okay? And so I've explained that to people dozens and dozens of times. I finally put together a little video that illustrates that. So that's a short little 1-minute video. We've got some videos on a simple house. So this house that we're doing right now, here's a real quick, it's like a, I don't know, how long is it, 6-minute video. I've got one on a 2-story house down here and stuff like that. So feel free to check those out. Also on our website, hvacmodel.com. I keep mentioning the downloads. So there is a downloads page. If you click on that, so there's a sample house that's completed. So if you have the software and you want to download a complete project that's done, that's got the loads done, it's got the ducts done and everything, this 1-story simple house is there. You can download that. Here's our step-by-step instructions. This is the installer. So if you want to download the software, you can download the entire file, the software file, for free. And then to purchase the software, you have to buy a key that unlocks it, okay? But you can get a 30-day free trial. This is where you would go. You would click this. You would download this file. Then you would get a 30-day free trial key. You'd install the software, tell it the key, and then you can use the software for free for 30 days. There's a little watermark across the screen reminding you that it's a trial version and all that other stuff. But you can try it out. And then when you buy the full version, you get a different key and it unlocks the full version. Okay. There's some instructions here. When I do the field draw demo, one thing that a lot of people have a hard time doing is going out to an existing home. You know, they called out to a house and they need to do load calcs on that existing home. One of the first things you need to do is draw a really crude floor plan of that house. And I have instructions on how to do that, how to go out to a house and measure it and draw it. And so it helps you know what you need to know and what you don't need to know. So it kind of streamlines the process for you. So that's there as well. And then that can be used in our field draw feature, which we'll talk about. Okay. So feel free to take a minute, or feel free to visit our website when you have a chance. I have an HVAC blog that a lot of you guys know about. It's called russellking.me, and I have a lot of posts there. I don't post very often, but I've been posting for a very long time. So there's quite a few stuff there. We'll talk about friction rate tomorrow, and that's a really hard concept to get your brain around. Friction rate is what you use to size ducts. You know your airflow and your friction rate, and you use that in a ductulator to size ducts. Understanding exactly what a friction rate is. It'll be numbers like 0.1 inches of water column per 100 feet. What the heck does that mean? And so here's a little blog article that kind of explains that. Another one that is a pretty popular one is how to quickly evaluate a residential HVAC system. I get asked all the time, hey, I sketched up this duct system. Does it look okay to you? I'm like, well, they'll sketch it up on a cocktail napkin and they'll show it to me and say, hey, does this look okay to you? And I'm like, well, I mean, I'm an engineer. I need to do manual JS and D on this thing. But there's actually a way to kind of really quickly look at this sketch.
I'm not seeing it on my screen, by the way.
Oh, sorry. Oh, that's because I didn't do it. Oh, my bad.
Also, someone's saying it's interesting that a 2x4 R13 in right suite has a framing fraction of 0.25 as opposed to energy gauge, which has a 0.15. So,
if it has a 0.25, it's a different spacing between the framing. It would be a 24-inch on center framing instead of a 16-inch on the center. That's what changes the framing factor is what is the spacing of the studs between each other. So I'm not sure, you might want to double check that to see. Here, sorry, I was talking about my blog, but I didn't have it on the screen where you can see it. So this is that blog article about how to quickly evaluate a residential HVAC system. So someone might hand me something as simple as this and say, hey, does this look okay to you? And, you might kind of say, well, yeah, but, what's the tonnage? What's your airflow? What's your friction rate? How much air are you trying to get to each room and stuff like that? There's actually a way you can kind of look at it and evaluate it pretty quickly. And that's what this blog article is about.
You're saying it is a 2x4. I'm not actually sure.
2x4 at 16-inch on center will have a different friction rate than 2x4 at 24-inch. Framing factor. Thank you. Framing factor. So that's probably what it is. If the framing factor is changing, it's probably changing the spacing between the studs. Because the framing factor is basically you're looking at a wall and saying what % of that total area of wall is wood. Okay, so 2x4 at 24 is 0.22. Interesting. Yeah, I'm not sure why that is. Not sure why it's changing in right suite like that. So in our software, you would look it up in Manual J. You would say, okay, I've got this wall. What does Manual J say the friction factor is for this kind of wall? And you type that in, and then it'll do the correct framing factor. I just keep saying friction rate. Friction factor. Yeah. Framing factor. Sorry. Okay. All right. Our break is long over past due. Let me go back to
that exactly time.
Oh, perfect. Where was I? Let's go back to sharing the software.
I think you're just about to place registers before or something like that.
Oh yeah, I showed you. I showed you in HVAC draw that the air handler has a shadow underneath it. And I was just about to give you a little preview of something we're going to do tomorrow, and that is when we place registers. I put this little register there, a little supply register. There's a shadow.
There was a, sure, this has turned out.
Oh, never mind. I think it's because I'm in a weird mode. Let me go back to the room.
Oh, uncheck and recheck shadows. Go back to HVAC draw. Uncheck and recheck the shadows. Okay.
Oh, there we go.
Still not showing up there.
No, it is. It was hidden behind the window. So that's what I was trying to show you is this is a supply register in the ceiling of this house, and it casts a shadow on the floor, which helps you line it up better with, you know, if you want to center it on your windows and stuff like that. Okay. And then here's another, this is one of my very favorite things. I'm getting ahead of myself. This is just a preview, a teaser to get you guys to show up tomorrow. Alt, not shift. Okay, so I put a start collar on that supply plenum. Then I click on Flex Ducts, highlight the start collar, highlight that supply register, and I hit enter, and boom, there's a duct there. And that Flex Duct. I'm going to move it around. There's a handle here. You can change it and stretch out all this stuff. And then tomorrow, and it draws it based on a default diameter. So it's defaults to 12. If you want it to be 8, change it to an 8. But you can move it all around. You can turn those into TYs in a register. Another register over here. Flex duct. Click enter. Big 6-inch. Okay. So we'll talk all about this tomorrow. We'll draw the ducts, we'll size the ducts based on the airflow, but in order to get our airflow, we need to know each room's load, and then we add those all together to size our equipment. And once we size our equipment, we can then determine an airflow, and that airflow gets distributed to the rooms, which is how we're going to size our ducts. Okay, so that's where we are. I was just going to give you a preview, so let me delete these teasers here. Oops. Okay, back to where we were. So we've got our house, we've got our walls, floors, ceilings, windows, all that stuff is specified how we want it. We've told it that there's one system in it. All right, now we click on Energy Gauge Loads. Energy Gauge is a different software program, but the Energy Gauge and Quick Model work together. They behind the scenes, so you don't have to open it. You install one, they install together, and all that other stuff. So I'm going to click Energy Gauge Loads, and it very smartly says, "Hey, you better save your file," which I should have done. Which I should have done several times before now. But it's reminding you, save your file. So I'm going to hit confirm. I'm going to call it the SCE Training House, which it's already named that. So there, now it's saved. Now it's going to open up Energy Gauge. And I think I have to change. Yep. Okay. I have to select a different screen. You see it now? Okay, so this little window that you're seeing now, oh, I can't put it down. It's chopping it off.
It's up there.
Oh, there we go. Okay, so we'll make sure you guys can see the whole. So when I click that Energy Gauge button, this little window pops up, and this is Energy Gauge. Okay, it says up here, Energy Gauge USA with Acca Manual J loads input. So This is manual J. Manual J needs to know your climate. It needs to know what kind of cooling system you have, what kind of heating system you have. It needs to know your infiltration on your house. It needs to know your duct leakage on your house in order to do calculations. That's all done through energy gauge, okay? So the first thing I'm going to do, and this is in your step-by-step instructions. Let me get that in front of me so I'm following it. Energy gauge loads. Number one, confirm that you want to save your work. We just did that. Save it under the same name or a new name. Then when energy gauge opens, it says click change climate, which is actually edit in this case. Edit the climate location. So I'm going to click this button here. And it defaults to Florida, Tampa, Florida, probably because that's where energy gauge is from. And I'm gonna do a house in California. I'm gonna pick California, and let's say Sacramento. I'm familiar with Sacramento, and let's just do Metro, Sacramento. All right, so by picking that state and that city, it has set all these other numbers, all right? It has set the latitude, the longitude, the altitude, the time zone, the average temperature difference. Those don't make a lot of sense to us. The important numbers are over here. The 99, so winter design parameters, the 99% design temperature for Sacramento in the winter is 30 degrees, all right, for this TMY thing. For manual J, it's 34 degrees. This TMY is more of an energy modeling thing. This manual J is what manual J wants you to use, okay? So that's 34. This median of extremes is used for, has to do with thermal mass and stuff like that. But this is the important number here. This is saying our winter design temperature for Sacramento is 34 degrees, okay? Our summer design temperature in Sacramento is manual J 1% is 98, okay? Sacramento is a dry climate, so we don't have to worry too much about our wet bulb and our grains and all that other stuff. But if we were doing a design in Florida, then those numbers start becoming important because we'll talk about latent load versus sensible load and stuff like that, okay? But by picking this state and this city, these are all built into the database, and it sets those for you, okay? Now, I get asked a lot, can I change those? And manual J does not want you to change those, neither does energy gauge. But if you were curious as to how the loads would change, if I were to change the outdoor temperature from 98 to 102, okay? What you would have to do is just pick a different city. That's all you do. You pick a different city with a different temperature there, okay? Allowing you to change this number, the way manual J feels about it and the way energy gauge feels about it is you're not doing a proper manual J, okay? Manual J, if you read the fine print in manual J, unless you really, really have a reason to, you're not supposed to change those temperatures, okay?
Now, try.
If you type it in there, it won't.
Oh, okay.
It's not looks like an input. Yeah, it looks like an input, but it's not.
Okay.
But again, if you wanted to change that just to see and say, man, I think 98 is kind of low for Sacramento. Gosh, just a couple months ago, it was 104 degrees in Sacramento. What's the load like when it's 104 degrees? Well, just go find a city that has 140 degrees and just change it to that. And
probably one in Arizona.
Yeah, Vegas. There's plenty in California. Palm Springs, Bakersfield is probably 102, 103. Let's see, Las Vegas, I want to say it's like 115 outside. So if you're just curious, just pick a different city and it'll change it for you, okay? All right, so we picked Sacramento, so it set all those stuff for it. That's our outdoor temperatures, okay? That's all our outdoor temperatures. We're gonna go back to this. Up here is where you set your indoor temperatures. And again, those are fixed by Manual J. Manual J says In the winter, use 68, and then the summer, use 75. If you want to play with those, it has the same impact as playing with your outdoor temperatures. It's a delta T. So the difference between summer inside and summer outside, whatever that delta T is, if you pick a different indoor and a different outdoor and get a different delta T, it'll calculate your loads accordingly. So so there you go. That's what Manual J says to use. We've asked them several times if we could please make that an editable number, and they philosophically don't think that's correct. And if you were to ask Hank Rutowski, the guy who wrote Manual J, he would agree with that. So they're being, strict about that, which is fine. That's, if you're doing Manual J, you follow Manual J, okay? And we could debate that all night, but let's not. All right. So the next thing is, remember we only specified one system. Had we left two systems on that little house, they would show up here, FAU1 and FAU2. All right. Since there's only one, I'm going to go in, I'm going to edit the cooling, and it says there are no cooling systems. Please check the plus box to add one. So here's the little plus box. I click that, and it says, what type is it? It's a central. Here's all your choices. Okay. I'm going to go ahead and call it a central split. But there's a lot of different choices you can pick here. Small duct high velocity, like a Unico system, package units, what else here? Geothermal, natural heat pump, all kinds of different stuff you can do up here. Okay, so we're going to do a central split, and then you have to say, okay, this system is assigned to what block? Well, we only have one, so there we go. That's easy. If the system was ductless, you would check this box here. And it's not going to ask you to define a duct system for this air conditioning system. But we do have duct systems, so we'll leave that alone. What else? I think that's about it for air conditioning. As far as Manual J goes, that's all it really wants to know. All right. So now I can use this little button here and skip to the heating system, or I can go back to where we were and click on the heating system here.
Dob says, sometimes we have clients who don't want Manual J, but want it well designed for them.
That's not Manual J, Dob. You know that.
Well, but I think that's really.
I know Dob's trying to poke my buttons on you. Yeah, I agree. So pick a different city. Yeah, with a different design temperature to do it. Yeah, there's ways around it. There's ways around it by picking different cities. And there's also ways around it by looking in Manual J. If you have an actual copy of Manual J and you see these tables, one column is going to be for a certain range of delta T's. The next column over is going to be for a different range of delta T's. And you can look right in that table and say, what's the difference if I have this delta T versus this delta T on that wall? And then you can sort of play around with the numbers that way too. So it's possible. It's doable. It's just not recommended. All right, so we need a heating system. So hit the plus sign. You can do electric heat pump, strip heat, baseboard, natural gas furnace. I'm going to keep it simple. Let's just go with the natural gas furnace. There's no subtypes for that. If you want to put in the model numbers here, you can. It's a little early for that. You have to tell it which system we're talking about. There's only one. Again, if it's ductless, and then there's a place to put a comment. Yeah, there if you want to.
Also, I don't know if he said that, but it shows all the rooms that are in the system.
Yeah, yeah. So if you remember, if we had two systems, some of these rooms would be assigned to one, and some of these rooms would be assigned to another, and it'll show those rooms in the list. It kind of reminds you, if you go, oh gosh, which rooms was FAU1 and which rooms are FAU2? Well, it lists them right down here for you. Okay. All right. The next thing is duct system. So I'm going to go back. We got that. We got that. We got that. Now we're on duct systems. So click that. Again, instead of going back to that screen and clicking on, there's these little shortcut buttons here. So from the duct screen, I can go straight to the cooling or straight to the heating screen there.
Energy gauge doesn't usually like that though. They kind of want you to go in order. I've had it like pop-up errors for me.
Oh, really?
Like you don't have a cooling system yet.
Oh, if you don't define something and you try to go to the next one, it'll say, wait a second, before you leave, you got to finish doing something. So yeah, it will do these errors. All right, now duct system, it needs to know quite a bit more information. So you'll see up here, it says supply duct R value, return duct R value, supply duct area and return duct area. Now, it'll automatically calculate the areas of the ducts based on a formula that's built into Manual J. But if you know, for some reason, if you do a design, and for you California folks, there's something called verified duct design. It's actually an energy credit you can take for designing your duct system to be really short and have really short runs and have less surface area. You can plug those numbers in here, but I encourage you, unless you know otherwise, just use the default numbers that they provide here. Supply duct location, return duct location. So this is where you would specify, are your ducts in an attic? Are they on the exterior? Are they up on the roof? Or are they in one of the rooms? If the ducts are in conditioned space, just pick any one of the rooms is fine, and it'll just know that that's conditioned space. It doesn't really matter which room you pick, it'll just know. So we're going to leave these in the attic, okay? And where is the air handler? And I drew it in the attic, so that's where I can put it. It allows you to, even if you draw it in the attic, it allows you to specify, because you might have drawn it in the attic, but you might have just put it there to be more neat so you can draw your ducts more easily, but it's actually in conditioned space. So we didn't link this location to the drawing, so that if you drew it somewhere, it automatically chose it here. We allow you to pick. So the bad part of that is you have to remember to pick it. Okay, so there's the attic. And then the duct conditions, pretty much use standard. There's these other things in here. There's these IECC stuff for buried ducts. If you're going to bury your ducts and you know what that means and you want to take credit for that, you can certainly specify that. All right, and then over here it says, assign this duct system to which heating and cooling system. So we only have one of each, so that's easy. And then blower and heat, not included in performance data. Don't worry about that. That's if you have an inline blower and that heat from that blower is not automatically accounted for, you can specify it here. But generally speaking, that's already been accounted for, and it's not a huge deal either. Okay, so we've got our cooling system, we've got our heating system, we've got our duct system. The last thing is, if you know that this house has some sort of mechanical ventilation in it, you can specify that. So you get the plus sign to create it. Your choices are fans or ERV, runtime vent with a minimum runtime vent with a backup. 99% of the time, it's going to be fans or ERV, okay? So let's say this house has a 50 CFM fan that's running 24 hours a day. It's an exhaust fan. That's their mechanical ventilation. They did some sort of ASHRAE ASHRAE 62.2 calculation. They said this little house needs, to meet ASHRAE 62.2, needs 50 CFM exhaust 24 hours a day. So I'm going to type in 50 CFM exhaust, and it's running 100% of the time. If it was on a timer, you would have to know what percent of the time does it run. Is it half the time? Is it a third of the time? So if it's on like a 5 minutes per hour schedule, you'd have to say, what's 5 divided by 60? That's a certain percent. You would put that percent, okay? If it was, this is exhaust only. If it was supply, you would type it up here under supply. Exhaust fans meeting ASHRAE 62.2 is really, really common in California and probably most other places. It's the cheapest way for a builder to meet the mechanical ventilation requirements. However, a lot of custom homes, a lot of higher end homes, a lot of nicer tract homes, a lot of subdivisions have an option where you can put in an ERV, HRV. And if you do, you would type in a supply CFM and an exhaust CFM, and what percent does it run? Okay, a lot of them run 24/7. And then what is the wattage? And what is the ERV efficiency? Okay, and ERVs are rated with certain efficiencies, so you would type it in here. And remember, all we're doing is we're accounting for load calculations. This is how many BTUs is this system putting into the house? And this is the information that Manual J needs to know to do that. But we're just doing a really simple 50 CFM exhaust fan running all the time, and let's say it's 50 watts. Okay, so we'll type in 50 watts. There is no efficiency. It's not an ERV, so that stays 0. And then what block does it serve? There's only one to choose from, so there we go. Okay, so we've just entered this mechanical exhaust system, and I need to speed up a little bit because I didn't realize time was flying. We've got about 30 minutes left, and if we don't get to something today, we can certainly pick it up tomorrow night. All right, so go back. So we've got our cooling system, our heating system, our duct system, our mechanical ventilation. We've got our indoor temperatures. It's asking here, infiltration, how do you want it to calculate infiltration? And so you can use default manual J, and you can look in manual J. I actually have a, in the downloads, I think I have a little chart that are little explanatory instructions that talk about this in a lot more detail. So you can have it do default manual J, or you can say other. And if you check this other box, it's going to ask you for some information. Your winter air changes per hour and your summer air changes per hour. You can, and this instructions that I mentioned will explain how to do this. If you have a blower door test number, a CFM 50 test number for a house, you can convert that to a summer and winter air changes per hour. Type that in here, and it will base your load counts on those numbers. Okay. But right now, you just all you have to do is convert it to ACH. It's a little bit of math, and I'll provide instructions on how to do that. Okay. This AED, adequate exposure diversity. Yeah, manual J. What it does is it looks at a house and it looks at how the windows are organized on a house. Are they all lumped on one side or not? And the vast majority of time, you're going to use AED for summer. And what it's going to do is it's going to evaluate whether all the windows, there's so many windows on one side of the house that affects the time of day that the peak load occurs. Okay. And if it does, it will adjust the loads accordingly. But I would say, unless you really, really know what you're doing and understand this, just leave this first box checked for now. And then read manual J about what adequate exposure diversity, or AED, what that is. Okay. All right. I forgot to do something. I did. I'm surprised nobody mentioned it. I forgot to say how many people were in our house, and that's through the rooms. Okay. So what I'm going to do is I'm going to save everything we've done so far, save inputs, and return to quick model.
Drag the window up really quick before you do that.
Oh, really? You see it?
Yeah.
This bottom button here says save inputs and return to quick model. I want to click that. I'm going to go back to quick model because I forgot to do something because I wasn't following my step-by-step instructions like I was supposed to. I got distracted. And go back to the data tab, which is where we are. Go back to the room tab, which is where we are. And there was this column here, two columns actually, that I forgot to specify. Room type and number of occupants. Okay. So room type, there's only three choices: other, bedroom, or kitchen. And those come from our libraries. We can go back in the libraries and see those choices there. Okay. So a kitchen is a kitchen. So I specify kitchen. A bedroom is a bedroom. A living room is another. A bedroom is a bedroom. And a bathroom is another. Okay. So now I've specified the room types. Built into these room types, especially for kitchen, is internal gains associated with kitchen appliances, such as your stove, your oven, your refrigerator, your microwave. Those add heat to the house and increase your cooling loads. Okay, so that's where you would specify that. If I were to go into libraries and look at, if you wanted to change that for any reason, go into room types, kitchen, and there you go. 1200 BTUs per hour sensible gain associated with kitchen. That's a very standard number, and 1,000 associated for latent. If you knew that a particular room in the house was going to be a recording studio, and you knew that there was going to be a certain amount of electrical equipment in that room running during peak time of day, you can plug that number. You convert the watts of what you think into BTUs, and you could add a room type, call called recording studio, and then specify one of your rooms to be the room type.
Does it also account for exhaust fans?
Exhaust fans are accounted for in only the mechanical ventilation exhaust fan. Exhaust fans for bathrooms and kitchen hoods and stuff like that actually don't get calculated in the load count. That would be kind of too much of a worst case. So the assumption is that when it's really, really hot outside and it's the peak design temperature outside, don't run your exhaust fans. Is basically what Manual J is telling you. So you could put that in there. You could put that into your exhaust system. Let me get back to that in just a second. Before I do that, I don't want to forget to put the number of occupants. So the general rule of thumb for the number of occupants is you take the number of bedrooms in the house plus 1. So this house has 2 bedrooms. 2 plus 1 is 3. So the number of occupants in this house is 3. If you know otherwise and can defend your assumption, you can put in a different number. But unless you know, do not let a homeowner tell you, I have parties with 50 people and I want you to size my air conditioning system for 50 people. Don't do that. That's not a good design practice. If you want to know how much impact it has, you can plug those numbers in, do the load calc and look at it, but I just highly recommend that you don't design your system that way. I'm not here to tell you how to design. I'm just telling you what Manual J says, okay? All right, so I've got number of bedrooms plus 1 is 3. Now I have to distribute those people. My general rule of thumb is I put the people where they're going to be at the hottest time of the day, which is in the late afternoon. So I've got 3 people to distribute. I'm going to put 2 in the living room. Oops, 2 in the living room, and I'm going to put 1 in the kitchen. Okay. So there you go. You can put those wherever you want to. Not a huge impact. Just don't put them all in one bedroom because it'll do weird things to the load in that bedroom. Just kind of spread them around in a logical manner, in a defensible manner. Okay. All right. So I got that in. I'm going to go back to energy gauge. Yes, I want to save. Thank you. Oh, that's time to open the window. Everyone saw me doing those walls, right? We saw it over there.
Yeah, okay. I think you're showing the whole screen right now is why.
Okay. All right, so back in here, I've got my people in there. What else? Oh, you know what I didn't mention in ducts, sorry. I forgot to talk about leakage. I did all this stuff and I skipped over here. I forgot to talk about leakage. All right, in California for new construction, the maximum allowed leakage, and you have to have it tested, is 5%. And so the way you do that as a percent is you click on proposed air leakage, and you come up here and you say 5%. That's pretty straightforward. If you know an actual leakage number, you can type that in. If you know that they don't leak, you can check that box. If you know the efficiency, in terms of an efficiency, if you know the efficiency of the duct system, you can type that in, or you can use a default for Manual J. I recommend that you use the percentage. So for new construction, it's 5%. For existing homes, alterations, it's 15% in California. Look at Manual J and see what they suggest for different situations and use an appropriate number there, okay? This return leak fraction is just saying, of all this leakage, how much is on the return side? Half is okay. It's a reasonable number. It depends on how you draw the ducts. I'm going to leave it at half. It's not that huge of a deal. I'm just going to leave it there to keep things simple. Okay. So now I think we're ready. And by the way, if you were following the step-by-step instructions, all that stuff I missed, I wouldn't have missed it. Okay. So I'm getting ahead of myself. I apologize. Now we're ready to click this button here. Calculate Acca MJ8 loads. MJ8 means Manual J version 8. Acca is Air Conditioning Contractors of America. If you're using a software, whatever it is, make sure it at least the load caps are approved by Acca, so it has this Acca logo on there. Okay, so I'm going to click this button, and it's going to do a load calc. That's it. It's done. Not very exciting. So what do we have? We have our winter delta T, so that's our indoor temperature minus our outdoor temperature. And our summer delta T is our outdoor temperature minus our indoor temperature. Okay, those are just informative. And then it has your winter building load broken down by building components. So I always look at the total first. So our total heating load for this house is that number right there. If you can't read it, it says 16,338. So when we size our furnace, we're going to want to make sure it meets that heating load. That 16,338, if you want to know where it's coming from, you look up here and you say, okay, 1,700 is from the windows, 2,788 from the walls, 1,234 from the ceiling, and so on and so forth. Here is our infiltration load. So when we did, we specified our infiltration method. That's where that number comes from. And if you do an exhaust ventilation system, it's an exhaust ventilation system is sucking air out of the house. And in order for that air to leave, it has to be made up by other air. So an exhaust ventilation system makes your infiltration worse. So this number goes up when you have an exhaust infiltration or exhaust ventilation system. All right, so this is all the totals. Here's our duct. Here's how much of our heating load is associated with our ducts. And there's this is a little misleading. It says no mechanical ventilation. Had I put in a supply ventilation system or a balanced ERV, HRV, there would be a number here. But when you model an exhaust ventilation system, that number is counted in the infiltration number. Okay, so be sure you understand that. That threw me out when I first saw that for sure. Excuse me. All right, so that's our winter heating load. Now, here's the complicated part. Let's look at our summer cooling load. So we've got two kinds of load. We have a sensible load and a latent load. And you add those two numbers together, your total sensible and your total latent, to get your total cooling load. Air conditioners, your cooling load has two parts to it, sensible and latent. Your cooling capacity of your air conditioner has two parts to it, sensible and latent. You want to make sure that the sensible meets the sensible capacity meets the sensible load, and the latent capacity meets the latent load. You don't want to make sure the totals match the totals, okay? Because there are different kinds of cooling. That's an all-day topic, talking about sensible load, latent load, and all that other stuff. So do a little additional research on that. Take my word for it at this point, but you're going to want to pick an air conditioner that meets this sensible, and then you want to check the latent capacity of your air conditioner and make sure it provides at least this much latent capacity. One of the many beautiful things about living on the West Coast in a dry climate is you don't have to worry too much about latent. When you pick an air conditioner to meet your sensible load, 99% of the time, it will automatically meet the latent load, because the latent load in a dry climate is so small compared to your sensible load. It's a smaller fraction of your total load. And most air conditioners, the sensible to latent capacity, sensible heat ratio is much higher than the California load sensible heat ratio. So it just works, okay? All right. If you were in Las Vegas, you might get this number up here. I'm sorry, this number here. And you would pick an air conditioner and say, okay, it meets that load. Then you come down here and look at the latent and go, whoa, wait a second. That latent load is much higher than the air conditioner I picked to meet my sensible load. So you would have to pick a bigger air conditioner purely because of your latent load, okay? So there's all that kind of stuff. This can get really complicated really fast. So I'd rather not kind of delve into that too much. Let's keep it simple for now and just say in a dry climate, pick it to meet this in a humid climate, check both of them, okay? And then read Manual S in your spare time to get a lot more detail on what we just talked about. Okay, so there is our loads, and the next step is to pick a piece of equipment that will meet those loads. I've kind of already gotten into that, but before I do that, I want to show you something. It's always very important to understand your loads. And the best way to do that is to look at detailed printouts. I emphasize, in fact, in my step-by-step instructions, one of the steps that you'll see a lot is double check yourself. Double check your loads, double check this, double check that. And one of the best ways to do that is up here are some reports. All right, so I click on this report tab. There's a summary, there's window exposure diversity, so that diversity thing I was mentioning, there's a printout for that. It has your winter whole house loads, your summer whole house loads, your winter by zones or rooms, and your summer by zones or rooms. So let's look at that one. So I'm going to click on this. This is your summer load calc broken down by zones. And Connor, I meant to tell them it still has this watermark right here. Oh, okay. Ignore that watermark. It's supposed to go away. And so what this does is you'll notice that it's 5 pages, page 1 of 5, okay? And it's broken up by rooms. So each room, here's our kitchen, we got our living, we got our bedroom 1, bedroom 2, and bath. Each room is going to have all this detail. And if you've ever looked at a Manual J worksheet, or if you looked at the Manual J worksheet in WriteSoft or Elite, this might look a little familiar. You'll see these windows, you'll see these numbers, you'll see these component summaries, you'll see these heat transfer multipliers. So this is all what Manual J does with those numbers we give it for the wall areas, the wall types, and all that. It goes and it looks at a table and it pulls a heat transfer multiplier out, and it multiplies that times an area of a certain type of wall to get a BTU. So this, BTUs per hour, I should say. So these are for the windows in this room, the kitchen, there's 2 windows. They are NFC rated, 0.35, 0.35, et cetera, et cetera, et cetera. If you have an overhang, it'll put this in here, and you can barely see it, but there's a heat transfer multiplier of 11 and 31, 11 and 87. You multiply that times the area, and it says this window accounts for 369 BTUs per hour of heat gain. This window accounts for 694 BTUs per hour of heat gain. All this stuff is going on behind the scenes. It's always a good idea before you actually pick your equipment is to just scan through this and make sure everything looks all right. Your walls, you got R13 there. Yeah, that looks good. These areas look okay. You know, I got a door in this room. Yeah, I got some ceiling. Just kind of scan through it really quick and look for numbers that don't seem to make sense, okay? Remember, we put a person in the kitchen. There's our person, has 230 plus the 1,200 BTUs of appliance internal load. There's that number. So here's our room load, 446.3. And this is only sensible. Okay. There's our bed 1. Go to the next page. There's the rest of bed 1. There's the living room, and it's all the rooms. So scan through this. It's good to get good at looking at these. It's worth it. I scan through these occasionally, and things will jump out at me, and I'm really glad that I looked through here and double checked it. All right, so always use these reports. You know, double check yourself. I like to double check my loads before I actually pick my equipment, because if I find out later that I made a mistake, then I have to pick my equipment all over again. All right, so we've got our load counts, we double checked them. Now we're ready to go pick our equipment. We've only got 5 minutes to do that, so we're gonna do most of that tomorrow, which is fine, we've got plenty of time. I say that now. I'm notorious for
5 minutes left.
Yeah, I'm notorious for talking too much. I apologize. But I will endeavor to be better tomorrow. So Manual S is a process for using those load calculations to pick equipment. The thing to realize about Manual S is equipment, especially air conditioning equipment, changes depending on the conditions, the operating conditions that you are installing it in. And by operating conditions, I mean, what is the outdoor temperature? A 3-ton air conditioner in Los Angeles will provide a different amount of cooling capacity than the exact 3-ton air conditioner installed in Las Vegas. Los Angeles versus Las Vegas, okay? So you need to know that. You need to know, will my 3-ton air conditioner meet my load in Los Angeles, or will my 3-ton air conditioner meet my load in Las Vegas? It'll give you two different numbers. So manual S is a procedure for figuring out how to determine what the actual installed capacity is depending on your design conditions, okay? So one design condition is outdoor temperature. Another design condition is indoor temperature and indoor humidity. Okay, we need to know that. That's usually a default assumption. The other one is airflow. A lot of people don't realize this, but if you undersize your ducts and you reduce your airflow across your evaporator coil, your cooling capacity goes down. Okay, and so your airflow, whether it's really high or really low, will change your amount of cooling capacity that your air conditioner will give you. And you're trying to size this to meet your load. And if you're close, undersizing your ducts may make your air conditioner too small, okay? And I will also throw this in. Not only will it make reducing airflow reduces your capacity, it also reduces your efficiency. It reduces your SEER rating on your air conditioner when you reduce airflow. So sizing ducts properly, knowing how to size your ducts to ensure a good airflow is important to sizing your air conditioner. So that's a big deal of manual S. All right, so we only have one block in this house, one system. So that's shown right here. It's called Edit Block 1. This says step 1, determine your loads. We did that. There's our loads summarized. There's our heating load 16. There's our cooling sensible load 11,762. We did that. There's a check mark there. Now we're sizing our equipment using manual S. So it says Edit Block 1. So if there were 2 or 3 systems, they would be lined up right here. So Edit Block 1. And then it kind of lays it out for you. Manual S, Acca Manual S has some guidelines for how much you can oversize air conditioners. It even has guidelines for how much you can undersize air conditioner. You are allowed to undersize your air conditioner a little bit. And by a little bit, I mean 10%. So here it says you can go down as low as where your cooling capacity is as low as 90% of your load. So that's undersizing by 10%. That is an acceptable design practice. You can oversize your air conditioner by as much as 15% or 115% of your load if it's a single speed condenser, okay? If it's a 2-speed condenser, you can go up to 120. If it's a variable speed condenser, you can go up to 130%. You can oversize by 30%. Okay, that is guidelines provided by Acca Manual S. If you're in a program where you need a rebate, and the rebate is contingent upon sizing to, doing manual J calculations and manual S and all that, you need to follow these guidelines. Okay, and it'll actually warn you if you go outside these guidelines. If you're not under those constraints, then it's up to you. I will just tell you this: oversizing air conditioners will cause just as many, if not more, comfort problems than undersizing air conditioners. Okay. Again, this is something we could debate all day long, and we don't have time. Sorry. Okay. So there's these steps here. Step 2 is where you can enter your AHRI data. So the way I typically do it is I do my load counts. I go through. I take a first rough guess at the size of the equipment. I go through the whole process, and then I go back and I fine tune it. So it's kind of a circular iterative process. That's just the way I do it. Some people are much more precise about it. That's fine. And so if you look at that load count and you use the exact same equipment at every project you do, you're an HVAC contractor, You always buy a certain type of equipment, a certain brand, a certain series of equipment, and you see that load calc number, you go, that's a 2.5 ton. I've done a dozen of these. Then you can type that number right in here. You can type in your AHRI certificate numbers, your efficiencies, and all that other stuff. I'm going to kind of do the simple generic version for you, and we'll do that tomorrow night, and we will have plenty of time for that. But I just want to explain why I'm going to skip over these for now. Step 3 is, so you fill out the rest of your stuff. Then one of the things you're going to tell it is right here. You're going to tell it how much CFM this air handler is going to provide at a certain static pressure. And we just did our load counts. We're going to go back to Quick Model, and it's going to take those numbers with us back to Quick Model. And when we go into the Data tab, you'll see now in the room table, each room has a load, and each room has a target airflow. And we're going to use that to size the ducts. So that's a preview for tomorrow.